A while ago we were tasked with creating a Christmas-themed Wonderland stage with the goal of celebrating the holiday spirit. With that, we've created an environment-focused stage consisting of various minigames and interactable activities all themed around the winter holidays, hence named the Winter Lobby. This tutorial aims to showcase the behind-the-scenes recreation of how the Wonderland was made. A .gil file of the final result is also provided for download to allow creators to reference it themselves. Note that for the sake of the tutorial, various features have been cleaned up and/or simplified to allow new creators to better follow along, so some aspects may be different from what was done previously. Despite that, we hope that creators, especially new ones, are able to learn from this tutorial in order to create a Wonderland of their dreams. Let's take a look at the map first. The map can be divided into 5 parts, which is Main Hall, Square, Town, Maze and Ice Skating Area. These areas also include some interactive minigames and props. Here is a brief overview of what they are: tic-tac-toe, whack-a-mole, basketball, snowball fight and ice skating. For the props and mechanics, we have a snow cart to help players refill their snowballs, and teleport points to travel between different areas. There are also candies help guide exploration, while granting speed buffs, and there are collectibles hidden across the map for players to search for. Lastly, there is a sled station where players can ride a sled to tour the entire map. Now let's move on to the area layout design for the Winter Hall. As you can see, I have an entity group on the side here. Since I didn't record the actual creation process, I'm using these groups to show the steps instead. First, if you're using a default file, you'll get grass like this. However, since the terrain options don't have the texture I want, I'm planning to use the built-in stone cube model instead. One thing to note here, you can let the terrain go below 0 on the y-axis. It's best to use these two entities as references to make sure they perfectly fit the ground at y=0. The map has a big playable range, so I made the ground extra large. Don't worry if it overflows. Next, use the terrain tool to lay out the town, blocking out specific zones for the square and the maze. Let's quickly go over how this terrain works. You can turn on grid lines inside the terrain editor. Then, just wrap it around like this. If you hold shift while dragging, you can see exactly where it's going to be placed. Next, press ESC to exit editing mode, and then you'll be able to adjust the terrain's position. Let's move the terrain down a little bit so it sits perfectly on the ground. If you want to create some height variations on the ground, simply click on the area above it. As for placing stairs, click on the ramp icon. Select Create from the UI, then hover your cursor over where you want to place the stairs. Pay attention to the arrow's direction, and keep in mind that stairs can only be placed on actual terrain. Next, add walls along the outer perimeter to further define the playable area. This also prevents players from seeing into the void. Make sure to disable the climbing feature for these perimeter walls. Here's a quick tip: you can lock specific increments in the bottom UI when placing assets. It lets you lock fixed numbers for moving, rotating, and scaling individually. Now, I'll do a quick demonstration of the wall placement. Most of the walls use stone cubes since they have a tiling texture that allows for seamless scaling. Try to add some pillars, extrusions, or recesses to the wall structures to break up the flat surfaces and enrich the details. Next, for the central area where the players spawn, I'm using the terrain tools to paint it. We'll go with stone as our primary material, and use grass texture for accents. Let's add some details to make the structure feel more complete. We can place a Christmas tree right here in the center, so players get an instant holiday vibe as soon as they spawn. For now, I'm just going to reserve a spot for it. Next up, we're going to work on the maze structure right next to it. Let's dive into the specifics of my design process for the maze. I'm using a grid-based approach to nail down the foundation and proportions. Don't forget to use the value fixed feature. Once that's set up, you can just freely add walls within this boundary. It makes it super easy to make changes later on. Next, we're going to add some town-themed buildings and small wall inside to set the scene. You can overlap some of the buildings here to make the layout look more diverse. These buildings and wall naturally form these little alleyways, which we can use later on to hide secret collections. There's still an empty plot behind the town, and I'm planning to use this space for the sled station. Let's jump straight to the finished result. Remember to disable the climbing settings on the surrounding walls to stop players from falling out of bounds. To keep the buildings from looking too flat, I went ahead and added some structural depth with extrusions and recesses, and that goes for the interiors too. Next up, we're moving on to the fun game zone. Let's block out the corresponding platforms roughly. Here's a quick time lapse of the build. Whack-a-mole. Tic-tac-toe. Basketball. I'm planning to put a snowball minigame right here, and I'll drop in the polished art assets later on. Now, this part is ice skating. The skating resort is designed as a fairly open area because I really want players to skating around freely. I used white rocks to build it, and remember to disable climbing on them. To keep the open space from looking too monotonous, I added some cliff faces across the resort. Finally, inside the resort, I integrated some parkour platforms. Players can scale these to reach the high points of the skating area and catch an awesome view of the entire map. Before we decorating the environment, it is important to make sure that purely decorative entities should be set to static. The reason being, dynamic entities carry additional logic on it and can impact performance if too many are in scene. By switching to static, only essential information such as its position and collision is retained. Now, it's time to add all the map decorations and bring this place to life. For this section, I'll be using some custom models. Don't worry, the prefabs will be next parts of the video. As for picking out the decoration, I specifically selected assets featured with Christmas elements such as confectionery, stars, gift boxes, toys, and various red and white ornaments. Then, I'll pair them up with my custom-made gift boxes and Christmas tree models. Now, let's do a quick showcase. To be honest, a lot of things on this map went through endless revisions to get to where they are now. My initial design actually featured a complex network of paths to make it more intricate. But after getting feedback that it felt way too cluttered, I decided to open everything up and make it the clean, spacious layout you see today. Oh, remember to close the initially effective for snow decoration to make it behave more like real snow. And now, it's time for the Art Prefabs showcase. Due to the sheer number of models, I'll just give you a quick showcase here and talk about the materials I used. Let's check them out. Now we can go ahead and place the completed VFX into the map. Just scatter them around randomly, don't make it too dense. Put flora effect on the ground and aurora in the sky. Next, we can scatter the newly finished light objects around, just like we did with the decorations. I'm matching them up with pure light sources here to create various environmental lighting setups. Let me break down the settings for the pure light sources. You can go into menu, and scroll down to find the manage light source. Add new light source, then, you can adjust its color, intensity, range, and the effective render distance. Once you're done setting it up, just place it wherever you think fits best. Next, let's adjust the overall atmosphere. I'm choosing a nighttime setting here, which makes the lighting effects look so much better. In the terrain editing's asset bar, you'll see the environment configuration. From there, you can create a new environment preset. I won't go into too much detail about the settings themselves since they're pretty self-explanatory. You can play around with them yourself. It's actually a lot of fun. Just remember to check the player box at the very top of the settings, otherwise, the environment you set won't show up when you enter the game. Since the functionality for some of these prefabs hasn't been implemented yet, I'm just going to roughly mark out where everything should go for now. As for these candies, we can scatter them all over the place, mainly to guide players toward the minigame area and encourage them to explore. Next, we'll go through each minigame one by one. I'll explain the basic design idea and how each one works. We'll cover how players interact with it, the main gameplay logic, and how it's implemented in the Winter Hall. To make it easy to follow along, I've numbered all the components and node graphs in order for quick reference. Each number corresponds to a specific minigame, and I've listed them all right here. First, let's set up a simple teleportation component. The core idea is simple. Players will press the tab key to select their destination, and we'll teleport them there instantly based on their choice. So, our first step is to figure out how many teleport points we need and set up the corresponding options. Next, we need to adjust the size of the collision box that triggers the tab menu display. Now we can jump into the node graph. After placing the teleport prefabs in the scene, record their GUIDs and store them in a list. Make sure their positions in the list match their tab option IDs. For example, if the basketball minigame has a tab ID of 1, we'll place its GUID at index 1. This way, we can easily fetch the correct prefab. Then, we use the tab event node to get the player's selection, grab the corresponding prefab, and teleport the player right next to it. And just like that, our basic teleportation logic is complete. Next, we're going to implement the game's settlement logic. Our main goal is to encourage players to explore our winter lobby, so we decided to design a gift collection gameplay mechanic, where players can only exit after finding a certain number of gifts. The logic is straightforward. Players hunt for gifts around the map, and once they collect enough, the exit unlocks. To set this up, we'll need a gift prefab and an exit prefab. First, let's implement the logic for our gift prefab. We want the node graph to trigger when the player collides with a gift, so we'll need to add a collision trigger to the gift and a collision source to the player. Both components are required to fire the collision event. Since there are multiple gifts spread across the map, we'll give each one a unique ID, and then create a save state, essentially a Boolean list, on the player to track whether each specific gift has been collected. Next, let's dive into the node graph design. We'll start with an entering collision trigger event node to fire off the logic. Then, we fetch the player's record to check if they've already collected this gift. If the Boolean is false, we update the player's Boolean list and spawn a VFX to give them some satisfying visual feedback. We also need to increment the gift count variable. This will be used for the UI progress display, and more importantly, it'll serve as a key variable later to check if the player can trigger the final settlement. Next, let's move on to the exit prefab. Just like the teleportation logic, players will use the tab key to interact, so we need to add a tab component and set up the exit option. Since unlocking the exit depends on the number of gifts collected, we'll use a Boolean node graph to dynamically show or hide this tab option. Inside the client node interface, let's create a Boolean node and set up our logic. Returning true will display the tab option, while false keeps it hidden. Finally, we'll also add a nameplate component to let players know whether they've met the exit requirements. And just like that, we've completed our entire gift collection and exit logic. Next up, we'll implement a simple candy collection logic. We designed this primarily to guide players and drop hints about where to go as they explore the map. Along with this, we've also added a scoring system. Players can earn points by playing minigames in the lobby and then rank against each other on a leaderboard. This adds a nice competitive element to the game, keeping the overall experience engaging and fun. First, let's set up the candy prefab logic. Just like the gift collection, we'll add a collision component to the candy to trigger node events. Next is implementing the scoring system. We'll configure the player count in the game settings, add a leaderboard component to the UI, and link each player's variables, specifically, a player score variable we created. For the actual scoring logic, I'm using a composite node to bundle the basic nodes together. Since this scoring function will be reused all over the lobby, turning it into a composite node saves us from rewriting the same logic, heavily boosting our development efficiency. All that's left is the refresh logic. Once a player touches a candy, it needs to enter a cooldown period before reappearing, which prevents players from spamming points. We can easily implement this by using the disable model and timer nodes. Next up is the development of the basketball minigame. The core gameplay involves shooting basketballs into the hoop. To add a bit of a challenge, there will be a moving barrier in the middle that travels on a loop to block the player's shots. Successfully making a basket rewards points. Based on this gameplay, we'll be working with several core features: player classes, skill design, projectiles, motion devices and hitboxes. First, we'll set up a participation toggle using the tab key. Once a player confirms they want to play, we change their player class to switch their skill set into shooting mode. Next, we design the shooting skill itself. In the character section, select skills, choose aiming skill, and enter editor mode. Pick the animation you want and add an aiming state to set up the camera angle. From there, add a branch so that when the loop animation ends, it transitions directly into the projectile branch. Inside a client-side skill node, we will spawn the basketball. For the basketball to work, it needs a projectile component. Heading back to the character section's projectile interface, create a basketball projectile. Here, we configure its lifetime conditions, animation speed, direction, and hitbox, hit area range. Finally, make sure to destroy the object once the attack hit is triggered. And just like that, our basketball projectile is fully set up. Next up are the basketball hoop and the moving barrier. Their design logic is actually identical. We just need to set up hitboxes so they can detect collisions with the projectile. Once a collision occurs, the projectile will execute an attack on either the barrier or the hoop. By doing this, we can add a when attack hits event node to our character node graph to detect exactly what the basketball hit. From there, we can easily award points to the player based on the outcome. Next up is our fourth section, where I'll introduce how to build a whack-a-mole minigame. This part primarily focuses on game flow design, and we'll be heavily relying on timers to control both the game objects and the overall progression of the match. The prefabs we'll be using here include the game manager switch, gingerbread men, and a hammer. Players will interact via the tab key to join the game. Once a player joins, we need to temporarily disable the master switch to prevent other players from entering and disrupting the ongoing game loop. Just like we did in the basketball game, I'll first change the player's class and equip them with a custom smashing animation and skill. Then, we'll create a hammer prefab and use a follow motion device component to attach it directly to the player's hand, making the gameplay look much more dynamic. Once everything is initialized, we'll start a global timer on the stage entity, which will handle resetting all components when the game concludes. Next, we activate the movement states of the gingerbread men so they can randomly pop up for the player to whack. To manage them efficiently, I've added a general tag to all gingerbread men, and a specific secondary tag to the ones that are currently underground. This allows me to quickly fetch the exact list of available targets. The master switch will randomly select an underground gingerbread man at fixed intervals to pop up. Meanwhile, each gingerbread man runs its own individual timer to automatically retreat back into the ground after a short duration, repeating this loop. This process continues until the stage's global timer counts down to 0 and fires a "game ends" signal. The master switch will catch this event, ending the round and resetting all elements and the player back to their initial states. Next up is the sled, which is actually pretty straightforward. We just need to use the path movement feature inside the basic motion device component and directly set the sled's position waypoint by waypoint. The main purpose of the sled is to give players a quick tour of the entire map for a nice sightseeing experience. So, once a player gets on the sled, they can press the tab key to immediately kick off the pre-configured basic motion device. You can easily adjust the path coordinates and speed to your liking. Once the movement is complete, we can use the mover finished event node to trigger the next logic. In this case, when the sled reaches the final destination, I use this node to execute the script that destroys the sled object. Next up is the classic tic-tac-toe minigame that everyone knows and loves. Since this is a two-player game, it requires two players to join before the match can begin. Similar to the Whack-A-Mole game, it heavily relies on a structured game flow and well-sequenced logic to handle the entire game loop. For this setup, we'll be using a game master switch and grid cells as our core prefabs. What we are mainly designing here is the entire game loop, covering how players join, how the game starts, how it is played, how win or game over conditions are checked, how the game resets, and how players leave. We will use the game manager switch to lock in the active players, because only two players can play at a time. When a player presses the tab key to click join game, we update the joined player list, and the moment the list reaches two players, we can start the game immediately. To prevent any outside interference, we will completely hide the Join tab option, and we will also add a visual effect to the active players as a clear indicator of who is in the match. Once the game starts, players can begin marking cells on the board. To give players clear feedback on the board's status, we have added specific visual effects to each cell, and these effects are controlled by their own Boolean nodes. First is the selection effect, which shows up when the cell hasn't been claimed yet, the game is currently running, and a player is standing inside that specific cell. This exact same logic is applied to the cell's tab component because the two interaction rules are identical. The remaining two effects correspond to the respective players' marks, X and O. The status of each cell is managed through a condition variable, where -1 means empty, 0 means X, and 1 means O. So we only need to update this single condition variable during gameplay to manage the entire board state. After that, every time a player makes a mark, we need to check the board to see if they have met the win conditions. Since there are 8 possible winning combinations, where index 0 to 2 correspond to each row, 3 to 5 correspond to each column, and 6 to 7 correspond to the two diagonals, I created a condition integer list with a length of 8 on the game manager switch. Every time a player marks a cell, we update this condition list based on their symbol, adding 1 for X and subtracting 1 for O depending on the cell position the player marks. We will then add or subtract 1 from the corresponding condition elements. For example, if a player marks the first cell at index 0, the winning lines it affects are conditions 0, 3, and 6, so we will update these 3 specific conditions. After each update, if any number hits +3 or -3, it means that player has won, and we immediately trigger the victory visual effects, then simply wait for the players to either reset the game or leave the match. When a player chooses to leave the game, we just need to directly reset the game and update the joined player list, then clear the player's visual effects, and just like that, the entire tic-tac-toe game loop logic is complete. Moving on, we'll now be talking about the ice skating ring. For this setup, we'll be using the disruptor, detector, and the jump pad as our main prefabs. We will begin by first placing the skating initial node graph onto the character, where it will create and assign a skating disruptor to each player. These disruptors are then applied follow motion device, while also having their disruptors devices turned off. Next up is to set up the detector onto the map. The detector's main function is to detect whenever a character enters the ice skating ring, enable the ice skating mechanic by enabling the character disruptor assigned to the character. This is done by using a collision trigger that covers the entire skating ring. Taking a closer look, the detector uses when a character enters its collision trigger, turn on the assigned skating disruptor and start a timer for player update. When a character exits its collision trigger, turn off the assigned skating disruptor and stop the player update timer. What is this player update timer, you ask? We'll first have to take a look at the disruptor prefab. In this prefab, there are character disruptor devices on it, which handles how the character skates. They only differ by motion velocity and decay duration. As you can see from the node graph, Skating Disruptor contains the timer player update. This is a looping timer where it constantly changes where the character disruptor is placed by switching its follow motion device target. For demonstration purposes, the disruptor will have decoration to show where the prefab is. As you can see, the disruptor stays behind the character when outside the skating ring. After entering the ring, the disruptor then starts the player update timer and starts to constantly move and push the character by using the character disruptor device. This even occurs when the character is not moving, simulating a slippery effect on the ice. However, if the character is completely still, the slippery effect won't occur. This is because the player update also checks for the character motion speed. If the motion speed is less than or equal to 0, the character disruptor device is then turned off. The disruptor also has another timer called Jump Complete. For this, we have to take a look at the jump pad prefab. The jump pad uses a collision trigger to detect the character. When detecting the character, it enables the disruptor on the character to push them harder and make the character jump higher than usual. To be more specific, when a character enters the collision trigger, it turns off the disruptor's player update timer and changes the disruptor device to ID2, which has the stronger motion velocity. After that, trigger a short timer in disruptor that enables the character disruptor device again to allow them to skate. Next up is the content for our very last game, the Snowball Fight game. This is also a mini-game that requires a structured game flow, mainly divided into an invitation phase, a gameplay phase, and an ending phase. It requires at least 2 players to start the match, and all players can independently choose whether or not they want to participate. Once the game begins, one player will be randomly selected as the prey, and everyone else can earn a large amount of points by hitting them with snowballs. On top of that, in this snowball fight game, getting hit by a snowball will freeze the player, putting them into a brief state of crowd control, and the prey will change to a different player after a certain amount of time. As for the other mechanics, the number of snowballs in a player's hand is limited, so players must go to the snowball cart to replenish their snowballs before they can continue attacking. For this game, we only need a single game manager switch prefab, then players will use the tab key to start the game, and the remaining work involves creating the game flow, UI displays, and the snowball throwing skill. First, let's design the snowball throwing skill, which is the player's default skill. Even outside of the snowball fight game, players can throw snowballs at each other, it just won't award a lot of points or freeze them. This method is similar to the previous basketball skill design, where we first create the skill, select the animation, then create a snowball projectile and use the same logic to launch it, and that completes it. The difference here is that our snowballs have a limited quantity, so we select the snowball consumption here and set up the snowball resource under Skill Resource Management, and every time the skill is cast, it will consume this resource. Finally, we create a truck for replenishing snowballs, and once players interact with it using the tab key, it will directly refill the player's skill resources. Next is the design of the game logic where a player interacts to initiate the invitation, and all players will see a snowball fight invitation UI pop up with a countdown timer allowing them to decide whether to participate or not. Once the countdown ends, the system checks if there are at least 2 players and then opens the in-game UI for those who join to display the player currently being hunted as the prey. After that, when an attack hit event triggers, we check if the hit player is actually in the snowball fight game, and if they are, we apply water and ice element states to freeze them in place and execute the point scoring logic. We also kick off a timer so that once the time runs out it automatically switches to the next prey target. Finally, when the game ends, we reset all the related logic and wait for the next round of the game to begin. And that wraps up the entire development logic and process for the Winter Lobby game. I hope this tutorial series has given you a clearer understanding of how to structure game flows and build interactive mechanics like the ones we designed today. Thank you so much for watching and following along through this entire journey. I hope you can take these concepts and apply them to create even more amazing experiences in your own projects. Thank you again for your time and support. Next